Let's start here today with this problem, finding where the tangent line is horizontal for 2x minus xy equals, 2x minus xy minus 3x squared equal 4. And this is one possibly where we could maybe do this without implicit differentiation, but let's do it with implicit differentiation. Probably about the same either way we go, but a couple of points that we can make on this one. If we do it that way. All right, so yeah. Find where the tangent line. First of all, what does that mean, the tangent line is horizontal? Well, as far as the calculus perspective is concerned, the tangent line being horizontal means you got horizontal tangent line, and so the slope of that line is 0. So that means the derivative is 0, right? We're looking for dy over dx equaling 0. The derivative equals 0. That's what that means. And so that's our first step here, is to find what dy over dx is, and then we set it equal to 0 because it's the horizontal tangent. All right, so let's use implicit. So we ddx both sides. Of course, the first one, that's easy. It's just 2. The second one, well, we got the minus x times the y, so we got to do the product rule. So the derivative of the minus x is minus 1 times your y, and then take your minus x times your derivative of the y, which is 1, but it's a y. We're doing the derivative with respect to x, so that means we can get dy over dx. So all of this is the derivative of that. Is that okay? With me there? Product rule. And then we've got the derivative of the minus 3x squared, so that's minus 6x. And then ddx of 4, the derivative there is 0 because it's a constant. Okay, so now let's see here. We've got solving for dy over dx, so let's subtract the 2, add the y, and add the 6x to both sides. And we have minus x dy over dx equals negative 2 plus y plus 6x. And so last but not least, divide off the minus x, and so we've got dy over dx equals that, negative 2 plus 1 plus 6x over negative x. Okay, so that's previous problems. That's what we were doing. We're finding dy over dx. Now we're just making another application here. Let's find then when the tangent line is horizontal, and so tangent line is horizontal when dy over dx is 0. So basically what we want to solve is minus 2 plus y plus 6x over negative x. When does that equal 0? Well, first of all, we can get rid of that minus x. If we just multiply both sides by minus x, clear it off of that side, and really it goes away on this side too because it's 0 times that, so it's still equal to 0. So this is really what we're solving here. All right, so this brings up the next point here. The problem with this equation is it's got the x and the y still in it. And so one thing we can do here is, what this establishes is it's a relationship, I guess you might say, between x and y. It's an equation with x and y. Let's solve this for y, and then we'll decide where to go from there. Yeah, so just solve it for y. So we add 2 and subtract 6x. And solve that for y. Right? But that still doesn't answer the question, because the question was where the tangent line is horizontal. This just gives me, well, this is saying the y is equal to 2 minus 6x. That doesn't really tell me a place on the graph. That really helps me. So how do I use that? Well, if you look at it this way, So I've got this equation that has a relationship between x and y. And then I've got this equation, which is also a relationship between x and y. That's, if you think about it, that's a system. That's two equations in x and y. So I've got kind of a system here. I don't know if that does anything for you, but what I can do then is use these two as a system and solve that system. But here's what it boils down to. And this is why I solved it for y here. If I take this and go back to the original equation and plug that in for y, what that does is that then gives me just an equation in one variable x. And so that's how I'm going to find this. So take that and plug it in for y here. So I've got 2x minus x times y, which y is 2 minus 6x. Now we said minus 3x squared equals 4. So it's a little math problem, algebra problem now. Is that okay? See what I did there? So that'd be 2x minus 2x plus 6x squared. I'm just distributing the minus x here. And then minus 3x squared equals 4. Oh, this one works out nicely there. 2x minus 2x, that's going to go away. 6x squared minus 3x squared is 3x squared. So we've got 3x squared equals 4. Well, we divide that by 3. X squared equals 4/3, which would mean x is plus or minus the square root of 4/3. You do a little square root method solving technique there. So the answer to the question, where is the tangent line horizontal, that technically would guess would answer it. It's x equals plus or minus the square root of 4/3, which we can simplify however you want to there. Now, if it, I didn't ask it specifically, find the points where the tangent line is horizontal. This would be the x coordinate of the points. If we want the y coordinates also, well, we've also, we've got y. Y is going to be 2 minus 6 times x. So you just plug in. So the y's would be 2 minus 6, and then do plus or minus square root of 4/3, whatever version of that you want. But you see what I'm saying there? Okay. All right. Anything on that? Anything more? Okay, the other one here, to finish off our first embarking on implicit differentiation here, this section, is this one. Well, we found dy over dx, the first derivative. Let's look at one using implicit where we have to find the second derivative. So find second derivative for x squared minus 4y squared plus 2y equals 7. So we want to find the second derivative. Well, this is coming up here now because of how we're going to have to get this, because that's not going to be an easy one to solve for y equals, is it? Since we've got what we've got there. So we're going to have to use implicit differentiation to first of all get the first derivative, which is using the implicit, we've been calling it dy over dx, but it's y prime, also known as there. So yeah, let's use our implicit differentiation to find dy over dx. And then that's the first derivative, and so the second derivative would just come right off of that. Okay? So implicit says, well, you need a d dx both sides. First of all, see what you get. So we take the derivative with respect to x, so that'd be 2x. This is a y, we're doing the derivative with respect to x, so that'd be 8y minus 8y. But it's a y, so I need dy over dx. And same thing here, derivative is 2, but I need a dy over dx also for that one. And then right side is 0. Okay? Dy over dx is leave here. We're going to subtract the 2x then. And then factor off our dy over dx. Minus 8y plus 2 equals negative 2x. And then just divide that off. So dy over dx turns out is negative 2x over negative 8y plus 2. And I guess now that I see, since I'm seeing it here, that bottom has a factor of 2 in it. I can factor off common factor. So let's go ahead and do that, and then I can cancel 2 off with the top. So dy over dx, final answer here is negative x over negative 4y plus 1, or 1 minus 4y if you prefer. Okay, and there's a couple other things we can do, but we'll just stop there. That's not the answer we were seeking, though, because we were wanting the second derivative. Well, as we know, the second derivative is just the derivative of the first derivative. So the second derivative is just going to be the derivative of that guy. So I'm just going to take the derivative of this with respect to x. Well, as that is, that's a quotient, isn't it? So quotient rule is what I need to go with. So low 4y, negative 4y plus 1 times the derivative of the high. The high is just negative x, so the derivative is negative 1. And we're doing the derivative with respect to x, so it's just negative 1. Minus the high, negative x, times the derivative of the low. Well, again, we're doing the derivative with respect to x, and so the derivative of the negative 4y, it's a y. So the derivative would be, well, straight up power rule is just negative 4. But it is a y, and so what else do we need? dy over dx. The second part of that plus 1, derivative constant is 0. So the derivative of the low, the denominator is just negative 4 dy over dx. With me? Over low square. So let's clean that up a little bit here. That negative 1 we can distribute, so that'd be positive 4y minus 1. Minus x, so it'll be plus x, but then I've got a negative 4, so it winds up being negative 4x dy over dx over negative 4y plus 1 squared. Which that's a pretty good answer because it involves x, y, and notice it also involves the derivative dy over dx. So there's a couple of things we could do here. One thing we could do, if we wanted it only in terms of x's and y's, well, we could just go ahead and resubstitute back here in what dy over dx is. 4y minus 1 minus 4x, did that, times negative x over 4y, negative 4y plus 1. Yeah, so we just drop that in. which doesn't make it look any better, I guess, but. Now let me show you one other thing here, if we wanted to make it look better. And this is probably what they would do to get the answer in the back of the book, what they would have if you were checking there. You know, if you get here, usually on the test it's okay, then that. But let me just show you, just FYI here. What we can do here is take and multiply this thing by this denominator, negative 4y plus 1. I'm going to multiply by a negative 4y plus 1. Now if I do that on the top, then I also have to do it on the bottom. Which notice, it's going to go very well with this denominator here because that's just going to make that cubed, isn't it? Now here's the thing. Yeah, if I multiply this whole top by negative 4y plus 1, it does get multiplied by that, but it also gets multiplied by these over here, too. So you actually wind up having to kind of FOIL that. Yeah, so that'd be negative 16, so it's just basically these two times that. So negative 16y squared plus 4y plus 4y, and then minus 1. Just pulling those out. But good news is when I multiply this times this one, negative 4y plus 1's cancel. That's why the whole thing I did that. So that'll cancel with that, and so it'll just be positive 4x squared there. And then the bottom will be negative 4y plus 1 cubed. Because that times that, that's the first power. So it does clean up nicely there. Negative 16y squared plus 8y plus 4y squared over negative 4y plus 1 cubed. You know, that concern to get it to there, maybe not, because this would probably be just about as useful, but just to let you know. Okay. Any questions or concerns on that?